So rational equations play a significant role in many applications. One is something that we use all the time, which is the conversion between Fahrenheit and Celsius. The equation right here would convert Celsius C to Fahrenheit F for any given Celsius value. So F is equal to 9 over 5C plus 32. And we've got to solve for C. So the first step would be to subtract 32 on both sides, or move the 32 to the other side, which would give us 9 over 5C equal to F minus 32. Now I can multiply by 5 over 9 on both sides. So 5 over 9 multiplied by F minus 32 would be equal to 5 over 9 times 9 over 5C. And those just would go away, giving us 1. So C would be 5 over 9 F minus 32. And as we all know, 0 degrees Fahrenheit, 32 degrees Fahrenheit corresponds to 0 degrees Celsius. So if you plug in F is equal to 32, you would get the corresponding Celsius value. So here is another expression where we have to solve for n. And this is a rational expression also. So how do we go about doing that? The ultimate objective here is to isolate n. So the very first step should be to multiply by 2 on both sides. So 2s would be equal to n times a plus l. Now we're almost there. Do not distribute the n. Everything is factored already. We have n by itself and a plus l by itself. So all I have to do is to divide both sides by a plus l. So n would simply be equal to 2s divided by a plus l. So we have to solve for T2. So the very first step would be to multiply by L on both sides. So H times L would be equal to Ka multiplied by T1 minus T2. Common mistake would be to distribute the Ka immediately. Now, there's nothing wrong with that, but you're actually making things harder on yourself. Anytime we have a factored form, it is organized. So divide by that factor so that we can isolate T2 nicely. So if I divide on both sides by K times A, I would have HL over KA equals T1 minus T2. I'm going to move the T2 to the left-hand side and H times L over Ka to the right-hand side. So when that T2 moves to the left-hand side, we have T2 plus H times L over Ka equals T1. Move H times L over Ka to the other side. T2 would be equal to T1 minus H times L over K times A. Does that make sense? Oh, someone gave me an answer, and that person is actually correct. I made a mistake. It's not times, it's actually plus, negative HL over Ka plus T1. Was that Christine?
No, Professor, that was me.
Ah, okay, sorry about that, you were right.
Thank you.
Okay, so any questions on this? So Caribbean camel can travel 20 miles in 8 hours, carrying a 300-pound load on its back. At this rate, how far can the camel drive in 10 hours? So it's a standard formula. I'll call it V. Velocity is distance divided by time. We say 20 miles, I walk at a speed of 5 miles per hour. I run at a speed of 8 miles per hour. So the distance would be in miles divided by time in hours. So it's a standard formula. So we know that the velocity of the camel is 20 divided by 8 miles per hour. So we can cancel out the 4. So we get 5 over 2, which would give us 2.5 miles per hour. Now that we have the velocity, we can extend it to 10 hours. In other words, I'm just going to rewrite the distance formula D as V times T. V is 2.5 miles per hour. That's what I know about the camel. And let me write it this way. .5 miles per hour, and you've got to multiply that by time, and we know what the time is. The time is 10 hours, and it's always a great idea to keep the units with us. The reason being, especially if you take chemistry or physics or one of those courses in the future, you have to convert between units. So which is why I'm writing it as 2.5 miles per hour in words, multiplying it by the time, which is 10 hours. So the hours go away, and multiply the 10 with 2.5, you get 25, and the unit just appears as is. So whatever manipulation that you can do with variables can also be done with units. And especially when you get into chemistry and physics, when you do unit conversions, this would come very, very handy. So V is the velocity, D is the distance, and T is time. So the problem comes down to setting things up properly. So the concept, though, is the same. The number of papers per hour. So for Alan, it would be 1/6. For Steve, we do not know the time that Steve would take to complete the paper. That's what we're trying to find. So let's just call that Steve would complete the paper, one paper, in 4 hours, in X hours, because X is what we're trying to find. We do not know what Steve's time is. That's exactly what we're trying to find. But what we know is when we combine these two together, when they work together, that one paper can be completed in 4 hours. So Alan can complete one paper in 6 hours. Steve can complete one paper in X hours, which we do not know. But when we put them together, one paper can be completed in 4 hours. Now we just have to solve for X. How do we solve for X? We keep 1/x on one side and move 1/6 to the other side. We need a common denominator. The common denominator is 24. So 1 over x equals, we have to change the 4 to a 24, so we multiply and divide by 6. 6 over 24. We need to change the 6 to a 24. We multiply and divide by 4. 4 over 24, which would give us 1 over x equals, combine the numerator, which should be 6 minus 4, 2, divided by the common denominator, 24. So 1 over x would equal to 1 over 12. We can get the answer either by cross multiplication, which would give us x is equal to 12, or by direct comparison. Since it is 1 and 1 across the equal sign, it should imply that x must be equal to 12. So either you can do the cross multiplication trick that we've been doing to get an answer of 12, or in this case, a direct comparison is possible because I have 1 over x is equal to 1 over 12, which simply means x has to be 12.